Okay, we are simplifying fractions where I have a cube root or a fourth root or maybe even a fifth root in the denominator. I have to rationalize these denominators. So we're just talking about how to undo a cube root, you would cube something. Undo a fourth root, you would raise it to the fourth power, and so on. So here, first thing I might do here, remember that you could still reduce. So if they're both under a cube root, right, and I had something that reduced right there, I would reduce. Negative 3 over 4 doesn't reduce to anything. But I can do something about that negative to make my life a little bit better. Take it out. So now instead, I can call this negative 3 cube root of 3 over 5 cube root of 4. So that at least looks a little bit better. I don't have to worry about the negative under the root. It just comes out in front. Remember, you can do that anytime your index is odd. If you have an odd index and you're taking the root of a negative number, just pull it out. Okay, so I would also reduce the negative 3 over 5 if I could, right? Because they're not under roots. So if it was like, I don't know, negative 30 over 5, I could reduce the two of those. But unfortunately, there's no more reducing that I can do. So I need to get rid of that cube root of 4 downstairs. So the only way to undo a cube root is to cube it. So I multiply by the cube root of 4 over the cube root of 4 because that's really just 1. But I can't stop here because cube root of 4 times cube root of 4 is just cube root of 16 and I'm no better off. I have to do it one more time. So now you see I'm cubing a cube root. So all three of those multiplied together is just going to get me what? When I multiply these three together, what do I get? Isn't it just 4? It's the cube root of 64, but isn't that just 4? Right? Because when you cube a cube root, undoes itself, huh? Yes, so my new denominator is going to be 20. My numerator, I'm just going to multiply straight across, right? So I'll have negative 3 times the cube root of 3 times 4 times 4 is 12. What'd you say, 48? 48. And now I just have to check and see if that could be simplified any. So I asked myself, are there any perfect cubes that go into 48? There is one. What is it? 8. So that splits into the cube root of 8 over the cube root of 2. I mean, not over, but next to. No. 6. Just kidding around. Just kidding around. 8 times 6 is 48. But the cube root of 8 is 2. So my numerator is really negative 3 times 2 times the cube root of 6. Yeah, negative 6 cube root of 6 over 20. Can I simplify which? Yes, these are both not in roots with each other, so I can absolutely simplify the negative 6 over 20. And my final answer, negative 3 cube root of 6 all over 10. And there we have it. So when you are doing any of these, do any simplifying you can do because it'll just make your life easier. If there's something that cancels out in the beginning, great. If not, then you just kind of go with it. Do I have more on the back of these? Oh, good, I do. So let's try one on the back. Let's do a fourth root one. You want to do 9? Okay. Yeah. So 9 is a fourth root. Yes, right from the outset, 2 over 2, they're just gone. Right? They just reduce to be 1 over 1. So that'll be easier to deal with. Unfortunately, I can't reduce 2 over 125. I should ask myself, is 125 a perfect fourth? Because that could save us a lot of trouble. Nope. And neither, yeah. Okay. Oh well, too bad, so sad. So, it's up to you. I don't care how you do this part. If you're lazy and you don't want to write the fourth root of 125 3 more times, you can write it like this. I don't advise you doing this, though, but you can do it like that. Now, it's easy to know what the denominator is going to be. It's just going to be 125 because I'm going to have 3 of them from here, and then there's my 4th, so my denominator is just a 125. I don't know. With the numerator, you just have to make sure that you're doing 125 times 125 times 125 times 2. You have to cube the 125 and times it by 2. Wow, that's going to be ginormous. Wow, okay. So I'll get the 4th root of 3906250. Now, I'm sure there is a perfect 4th that goes into this. Maybe 625? Yep, 625 does. More than once. Oh my gosh. Fourth root of 625 times the 4th root of 6250. The 4th root of 625 is just 5, right? Yeah. So that's 5 times the 4th root of this. But then 625 goes in again. 10 times. It'll be 25. I get a 25 out here times the 4th root of 10 all over 125. And then I can reduce the 25 and the 125. So that's going to be 4th root of 10 over 5 in the end. Boy, that's a beast. The numbers usually don't get that, I mean, they can get that big, obviously, but usually we try and keep them smaller. Another 4th root one, and then I'll let you try some on your own. Great idea. Okay, how about, oh, let's do 13. What should you do first on 13? Yes, make your life so much easier. They're both 4th roots. 5 over 25 becomes 1 over 5. What is the 4th root of 1? It's just 1. So now I only have to deal with this 4th root of 5 in the denominator. So see if you can finish fixing that so that there will be no more radicals in my denominator. Okay, so again, I like to write them out so that I have 4 altogether. But if you're feeling lazy, well, it's not lazy, it's just, oh my gosh, what am I doing? What am I doing? Making mistakes. I can multiply by the 4th root of 5 over the 4th root of 5, and I need 3 more of them. So then altogether I'll have 1, 2, 3, 4. So my denominator will come out to just be, what's your denominator? Just a 5. In my numerator, I have to do 1 times the 4th root of 5 cubed, so that's the 4th root of 125. 5 times 5 times 5. Yep. And there's my answer. Do you agree? Everybody's all right? Okay. All right. Okay.